This rotating cube is not a blueprint mockup. It is a real actor class compiled in Unreal Engine 5.5, placed in a saved level and running in Play and Editor. In this lesson, we will build the class from the inside out, what UCLASS and generated body contribute, why components belong in the constructor, what BeginPlay is for, and how Tick uses delta seconds to create frame-independent motion. At the end, we will verify the visible result, the runtime log, and an automated regression test. The class begins as normal C++ inheritance. First, CPP-actor derives from AActor, which gives it a transform, a world lifetime, components, and gameplay callbacks. UCLASS registers the type with Unreal Reflection. The generated header must be the final include in this header, and generated body inserts declarations produced by Unreal Header Tool. The module export macro, first actor lesson API, makes the class visible across module boundaries. If any part of this contract is malformed, UHT fails before the native compiler reaches the implementation. The constructor defines the actor's default structure. We create a scene root, a visible cube mesh, a floor mesh, a point light, and a camera with CreateDefaultSubobject. Each child uses setup attachment, so the hierarchy is explicit. The camera receives a deterministic location and rotation, which makes the play and editor-proof repeatable. Constructors also run while Unreal creates class defaults, so they should establish components and default values. World-dependent gameplay belongs later, after the actor has entered a world. Rotation speed is ordinary float data, but UPROPERTY makes it visible to Unreal systems. Edit Anywhere exposes it on the class and placed instances. The category keeps the details panel readable, and clamp min and clamp max prevent unreasonable editor values. The C++ initializer sets the stable default to 45 degrees per second. In the real editor capture, the placed first CPP actor demo instance comes from this compiled class. This is the key bridge. C++ owns the behavior, while designers can safely tune selected data without recompiling. BeginPlay is the first callback in this lesson that depends on the running world. The implementation calls superFirst, finds player controller 0, and sets this actor as the view target so the camera component supplies the game view. It also writes the exact rotation speed to the output log. That log is evidence that the compiled class entered gameplay, not merely that the editor displayed a saved object. Use BeginPlay for runtime initialization that needs a world, other spawned actors, controllers, or gameplay state. Tick runs once per frame because the constructor explicitly enables it. Delta seconds is the time since the previous frame. Multiplying 45 degrees per second by delta seconds makes the accumulated rotation depend on elapsed time instead of frame count. A machine running at 30 frames per second and one running at 120 should rotate at approximately the same visible speed. The two real PIE frames were captured 1 second apart, and the cube orientation changes while the camera and floor remain fixed. Tick is useful here, but do not enable it for classes that have no per framework. Here is the complete proof chain. Unreal Build Tool compiled 12 actions and produced the editor module in 64.15 seconds. Unreal Editor loaded the class and saved first actor map with one placed instance. Play and Editor switched to the actor's camera and showed the rotating cube under the C++ point light. The output log recorded first CPP actor BeginPlay, rotation speed equals 45.0. The class, level, visible motion, and log all describe the same runtime behavior. A screenshot proves appearance, but it does not protect the C++ contract. The automation test reads the class default object and checks 5 invariants. Tick is enabled, rotation speed remains 45, and the mesh, camera, and point light components exist. This catches accidental changes that a single PIE frame could hide. The release gate therefore has 3 parts: a successful editor build, a passing automation test, and a real play and editor capture with the expected log. That combination is a practical AI coding loop: write, compile, test, run, observe, and only then publish. Remember the 3 jobs. The constructor creates default sub-objects and establishes the actor's reusable structure. BeginPlay initializes behavior that needs the running world. Tick performs repeated work and should use delta seconds when motion depends on time. UPROPERTY exposes carefully chosen data without moving the core behavior out of C++. In the next lesson, we will go deeper on UPROPERTY specifiers and build an editor-tunable actor without losing safe defaults.